Hi, my name is Jacqueline Lam, and today I'll be covering Lecture 6, Input Devices, with a focus on the resistive touchscreen. Here's a little bit of history on the touch input, and you would usually think that the touch input came from the PC, but it actually stemmed from early electronic music instruments such as the synthesizer or the touch-sensitive organ, and they basically use touch-sensitive capacitive sensors to control either sound or volume. And although early in the day, these inventions were based on touchpads, this idea will eventually advance to become the modern touchscreen. And so we can see that these musical innovations from early on paved its way for the touch input into modern PCs or even tablets and other technology. And so we can see the touch-sensitive organ on the picture on the right, which was created by Hugh LeCaine, and we can see that on the key right here, it has electrodes connected to it, and beneath the keyboard, there are also some electrodes as well. And so when you press down on the key, there's a certain force, and with more force, the electrodes will come closer together in proximity, which will produce more current and more volume. And so for a musician who's well accustomed to this kind of instrument, the touch-sensitive organ, it can provide really good control and range for each key. And so after the electronic musical instruments were invented, this touch-sensitive technology was built commercially for the first time in 1984 by Casio. And so you have probably heard of Casio as a company that makes calculators. So what they did was create or blended the calculator with a watch together, and it's basically an extra feature that they added. And as you can see in the video right here, that was a clock, and this is actually a calculator that's has digital keys that you can either press with a stylus or your finger. And this kind of technology you can see in today's products such as like the Apple Watch, which also has a touch screen kind of input as well. And so in the modern era, touchscreens are pretty much normal. You see these touchscreens when you're in the plane, and almost every Apple product or tablet has some kind of touchscreen. However, there's actually a technological difference between different touchscreens, and we're going to focus on two types. You probably felt actually like a physical difference between them. There's a resistive touch on the left picture right here, which is some kind of screen on the airplane, and on the right, which is an iPad, this is the capacitive touch. And like I mentioned before, you probably felt a physical difference between the two. The capacitive touch is more responsive and sensitive than the resistive touch. And the resistive touch, it requires a little bit more pressure to actually sense a touch input. So sometimes you might use a stylus to actually press on the resistive touch screen. And here's the structure of the resistive touch. It looks a little bit complicated over here, but we're just going to focus on a few main components to this resistive touch structure. So this is how it works. There's two layers right here, this top layer and this bottom layer that's coated with ITO or indium tin oxide that has uniform resistance across it, so that when you touch or press the top of the layer, which will deform a little bit as you can see right here, it will make contact with the bottom layer, and when this happens, the electrodes around the edge of the screen, so you have electrodes around this screen, or you have electrodes around here, they're able to measure this electric field change from when you touched or press on the top layer. and then the position can then be inferred or measured when you press on the screen. And so there's some circuit designs that allow for this kind of measurement. And one example is if we have two layers, so one layer is horizontal lines and another layer of vertical lines, and say you press right here, it's going to be able to measure that point of contact and possibly other lines around it as well. And so you'll have this area where it will create a uniform electric field around this position so that you're able to tell what position you basically touched. And a few other structures of the resistive touch on the screen. There's also a flexible PET film on the top layer right here, so that allows this layer to basically deform a little bit when you press on it. And there's also spacer dots printed on the bottom sheet, so like right here, right here, right here, or you can see right here as well. And this is basically to prevent the top and bottom sheets from accidentally touching, because you don't want to really register a touch when you don't want to, or when it's not actually pressed. And so here's an example of resistive touch when where it's an analog 4-wire resistive screen, and this is actually considered one of the most basic sensing methods for the resistive technology. And we can see that there's two layers, a top layer and a bottom layer. So we're going to consider the top layer to sense the x coordinate and the bottom to sense the y. For now, we're just going to stick to the top layer. And so say you have electrodes x1 and x2. So x1, x2, and they're parallel to the x-axis. A voltage is then applied so that there is now an equal potential distribution parallel to this line right here. And so what that means is basically if you touch somewhere on the line, it'll be able to register a certain signal and a corresponding position. So say we press in the middle of this x1, x2 line, the signal will probably return 2.5 volts, and that indicates that you press somewhere in the middle of the line. And the bottom layer, it senses the y coordinate. It basically works the same way as the x, as sensing the x coordinate on the top layer. And so here are a few pros and cons of the touchscreen. For the pros, we're basically easily able to update different controls for whatever functions we want. For example, we're at a dining hall at UCLA. Take the study, for example. You probably use the touchscreen kiosk, and instead of that, say we have mechanical inputs to order food. This would basically limit what foods, drinks, and different combinations we're able to order. So what this touchscreen would allow us to do is page through different screens, become a little bit more versatile and flexible in adding new food or drink options. And some cons to a touchscreen could be that it definitely costs more to implement it. It's better technology, so there's probably a cost correlated to it, and it's also error prone to human use. Sometimes it's also very sensitive, so there's a lot higher chance to accidentally touch the screen when you don't want to. And finally, here's an overview of the resistive touch. We can see that it's low in cost and power. The resistive touch is a lot more simpler in structure and technology than the capacitive touch. And the input materials that you can use to press down onto the resistive screen is anything that can basically press on it. So you can use your finger or a stylus, anything of that nature that will just apply some kind of force on it. And A slight disadvantage to the resistive touch is that it usually registers single touch rather than multiple touches, which is the case for the capacitive touch. So it's limited in that kind of aspect. Because of ITO properties, the visibility and durability is not that great for the resistive touch. So for like the durability, it's not good because of ITO shifting, and that just basically means that if you press down on a certain area on the screen, the cursor will appear somewhere else on the screen and not actually where your finger is actually pressing down. And there's also a size limit to a resistive touch screen. It's about 27 inches because it's a little bit difficult to make the ITO coding uniform. Also, one other property of the resistive touch is that it's less sensitive than the capacitive touch. So I guess it's just based on user preference on what kind of touch sensitivity they would like.